Welcome to challenge 15. Create a function that will find the nth Fibonacci number using recursion. So again, what is a Fibonacci? This is a series of numbers where each number is the sum of the two preceding numbers. So this is the sequence that we have: 0, 1, 1, 2, 3, 5, 8, 13. So to find the nth Fibonacci, let's say if we want the 10th, the 10th is 34. I'm just giving an example. Our function will take any number input, an n value. Then so let's just work with an example here to get how we're going to go about it. So the 10th over here is 34. How do we get 34? 34 is the sum of 13 and 21. 13 is 1 to 2 places from 34, and 21 is 1 place from 34. So function, so it's like if we want fn is equal to fn minus 1 plus n minus 2. So this is what our function would do. Essentially, this is what we want our function to do. So let's just create a function. So let's say function fibnum. Okay, this didn't go the way that I wanted. What's happening? Fibnum. Then it will take n. Then what will happen? We want it to use recursion. That means this function will call on itself. Like over here we have a function n, then our function n will be equal to function n minus 1 plus function n minus 2. So this is what we'll have. So it will it will return fibnum n minus 1 plus fibnum n minus 2 over there, and this is what we return, and this is what we want. But let's look at something over here. Let's look at something. What will happen when our n is equal to 1 or n is equal to 0? So this is the first number, the 0th position, then this is the 1 position. What will happen? So when it's 1 over here, we don't have 2 preceding numbers, and when it's 0 again, we don't have 2 preceding numbers, so that will cause an error. So these are best cases that we can prepare for by saying if the n is 0, if the n is 1, we return certain values. So when n is 0, we can just return the 0. When n is 1, we can just return 1. Then when it's now 2, it will work because we will now have 2 preceding numbers. So let's do that. So let's, if n is equal to 0, we will return 0. Return 0. Then enter. If n is equal to 1, we will return 1. So return 1 over there, and then if it's neither of these cases, we would then return fib num n minus 1 and fib num n minus 2. Let's save that. Then let's console.log console dot console dot log shift. Let's do this fib num, and let's go for 10. Control save, and let's run this. Oh yes, 10 is not 34. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so this will be the ninth over there. That was my mistake. Then over here, let's put 9. Control save. Let's clear this, and let's run this. Yes, so this is working, and this is how we use recursion. So recursion, we have the function calling itself, which is what's happening over here. The function is calling itself here and here. So, and just to give an illustration of how it is working, I'm going to use fib num 4. So when we have fib num 4, the fourth position 1, 0, 1, 2, 3, 4. The answer should be 3. Then when you run yes, we get 3. And now just to illustrate how it works, just through this diagram for the purposes of this. So fib 4, let's go through it. Let's just remove this so that we can see this better. Yes, so this is what we have. When we have 4 over here, when it's 4, we check is n equal to 0, no, is n equal to 1, and then it returns this 2. Fib num n minus 2 n minus 1. So it calls this function. This is calling this function again, because as you can see, we have the function fib now. It's calling this function, and this one again is calling this function. So when we call fib num 4, it calls fib num 3 and fib num 2, because n minus 2, 4 minus 2 is 2, this one, then 4 minus 1 is 3. And then this is what we have. And now we are calling fib, this function again. We're calling fib num 3. What is fib num 3? Fib num 3 is fib num 2 plus fib num 1. If you can look at this again, if it's 3 again, here become 3 minus 2 is 3 minus 2 is 1, and 3 minus 1 is 2. Then for the fib 2, it's calling fib num 1 and fib num 2. Now what happens here? When we have fib num 1, it comes into this. If n is equal to 1, we return 1 over there. Then for this one again, when it reaches this, we get 1. Then for fib num 0, it's 0. Then we come enter. Then when it comes to fib num 1 is 1. Then fib num 0 is 0. So this is what we have for the diagram. I hope this can actually help you understand that, because it did take some time for myself. Then I got to understand. So what we have here, we now go on to add. So 1 plus, we have 1 plus 0 here is 1. Then 1 plus 1 is 2. Then 2 plus 1 is 3. Then this is where we get the 3. That when we run over here, we get 3. This is where the 3 is coming from. So this is what happens even with higher order numbers. It just becomes a bit more complex, the diagram. But then this is actually what's happening with the Fibonacci. So these base values that we have over here are very important, because these are the ones and the zeros that we will be adding. So thank you.